Hey guys, so these are the solutions to your 5-1 to 5-5 practice test. Let's get started. Questions 1 and 2 ask you decide if these angles are complementary, supplementary, or neither. So let's just remind ourselves that complementary means they add to 90 degrees. One way I like to remember it is I can make a 9 out of that C, and it's like CO becomes 90. It's one way to remember it. And supplementary means they add to 180. One way I can make this a little memory trick is I can make an 8 out of the S in supplementary and just add a 1 in front. And I can kind of imagine my U becomes an 0. So all you have to do is add. So we will do 64 plus 26 and see what we get. Well, adding it nicely, this comes out beautiful to just 90 degrees, so we will call this complementary, which I'm going to abbreviate as comp. Question 2, 90 degrees plus 90 degrees, well, that's just 180 degrees. So right away, this is supplementary, which I'm going to abbreviate as sup. Moving on to questions 3 and 4. Now, we need to be able to recognize certain things in these pictures. Like on question 3, we have an intersection of two lines, and we have some values and expressions kind of at the corner on opposite sides of this intersection. Now, if you're in my class, I like to say you make a bow tie. And our bow tie knot is where they intersect, and the bow tie knot is 3x minus 4 and 107, and to make it a nice even bow tie, they have to be equal. So this is actually one way we start to set up our problem. Because these are called vertical angles, they are equal, meaning 3x minus 4 has to be equal to its other half of 107 degrees. So this becomes a two-step equation. Now remember, when we solve equations, don't call me after midnight. Right now, we just have to undo any adding or subtracting near our variable. Here's our variable. I see some subtraction as minus 4, so we will undo that with plus 4. This leaves me with 3x equals 111. Getting x by itself, I'm going to undo that secret multiplication with division, and I divide both sides by 3. So this tells me my final answer is x equals 37 degrees. If you'd like to see that long division, 111 goes in your house, 3 goes outside your house, 3 can go into 11 3 times, which is 9. Subtract, I get 2, bring down my remainder of 1, and 3 goes into 21 7 times. Number 4. Well, number 4 has a little box in the corner. Remember, this little box in the corner means 90 degrees. And what we just saw on question 1 was if two things add together and they make a 90-degree angle, or 90 degrees, then that's important for us to create this equation. So this picture is telling us 3x plus 2x equal or forms this 90-degree angle, this box in the corner. So that creates an equation. Well, here I can add like terms, or add things that are the same, which is 3x plus 2x, and that gives me 5x equals 90. To get x by itself, you can get undo that secret multiplication with division. So I'm undoing times 5 with dividing by 5, and this tells me x equals 18 degrees. Just in case you need to see that long division, 90 goes in your house and 5 goes outside your house. 5 can go into 9 one time. And this leaves me with a remainder of 4, and I bring down my 0, and 5 goes into 40 8 times. Then let's keep going. Question 5 and 6. Now it says find the value of x and then classify. This means give the triangles a name. Now there can be more than one name per triangle. When we start this problem, we need to remember that all the angles, so all the corners in a triangle, add up to be 180 degrees. So this means you have to add together everything you can. That would be 39 plus 125 plus x equals 180 degrees. This is a very formal way to show our works by creating an equation. Now mathematically all we are doing is adding the numbers together and subtracting by 180, but it's nice to bring back what you just were tested on last chapter. From here, if I add 39 and 125, we'd get 164 plus x equals 180 degrees. Getting x by itself, what I'm doing is subtracting that constant of 164, because it's a positive number. I'm undoing positives with minus. And this tells me x equals, when I do this subtraction, I just get 16. Because remember, you have to borrow from your 8, make it a 7, which makes 0 a 10. 10 minus 4 is 6. 7 minus 6 is 1. But finding my x value is only part of the problem. Now I need to give it a name. Well, what I notice is that I have an obtuse angle. I just need one obtuse angle. Obtuse means something is more than 90 degrees. So I have an angle that's more than 90 degrees. That's 125. So I can call this triangle an obtuse triangle. I'm going to draw the picture of a triangle because I don't feel like writing the word. But that would be its name. Now I do the same thing but on question 6. Now with question 6, when I start to add up the numbers, I need to remember that if I see a box in the corner, this means 90 degrees. So when I start to do this, I'm really adding 90 plus 45 plus x. And all triangles add to 180, so this is equal to 180. Adding my numbers, 90 and 45, we get 135 plus x equals 180. To get x by itself, what am I actually doing? I'm just subtracting. So this tells me x equals 45 degrees. Again, I can't do 0 minus 5, so I borrow from my 8, makes it a 7, which makes 0 a 10. But not done, because I need to name my triangle. Now, anytime you have a 90-degree angle, box in the corner, this means you have a right triangle. But this triangle actually has another name. If you're not sure what these little tick marks on the side of our triangle are, they represent, this is a little symbol that says, hey, whatever length these are, these two sides, they are the same. So it could be 4 inches and 4 inches. It can be 12 centimeters and 12 centimeters. Doesn't matter, but these tick marks say they have to be the same. What I also notice is that we have two angles that are the same. We have two 45-degree angles. Well, when you have two sides are the same and two angles that are the same, this is called isosceles. So this triangle actually has two names. It's a right isosceles triangle. It's important you know those names of all those triangles from section 5.2. All right, let's move on to 7 and 8. Moving pretty well through this practice test. This says, tell whether the triangle can be made with these angle measures. If not, change the first angle. So the only time you have to change the problem is if when you add these numbers together, if they don't equal 180. So let's just see what we get when we start to add. 35 3/4 plus 90 1/4. I'm going to just do one at a time. Then we'll add in the 55. When I'm adding here mixed numbers, I'm going to start with my fractions here. We have 3/4 plus 1/4. Well, wait a minute. Remember when you add and subtract fractions, the denominator, meaning the bottom, is the same. So you add your tops. 3 plus 1 is 4. 4 over 4 is 1 whole. So this is really adding an additional 1 to my answer. So let me just say plus 1 down here. Well, actually, I'll wait to say that. Let's do the other adding, and we'll add in this 1. So now let me add the whole numbers. 35 plus 90. Well, 5 plus 0 is 5. 9 plus 3 is 12, but I have to add my extra 1 for my fraction, my 1 whole. So I get 126. But I'm not done, because now I need to add that 55. and to see what we get from here. 6 plus 5 is 11. I carry my 1. 2 plus 5 is 7, plus my remainder is 8. And 1 plus technically 0 is 1. So I just added this up, and I got 181. Well, if it needs to be a triangle, it has to be 180. So no, this does not work. Now we have to pay attention, because this didn't work, we have to pay attention to the other part of the question. It says, if not, meaning it does not add to 180, we need to do something to the first angle. That means changing 35 3/4 so that if I re-add it with something else, it does equal 180. Well, we just compare the answer we got, which is 181, to what we want, which is 180. So I'm over by 1. So if I want to make sure this works, I need to be smaller by 1. So this, I can just change the whole number to be 34 3/4. Can stay the same. So what it means by changing it. Now if I re-added it, I could check my work, and if I did 34 3/4 plus 90 1/4 plus 55, this does equal 180. So I know it worked out. Now let's go to question 8 and let's add these decimals. 89.25 plus 74.55 plus 16.2. Now when you're adding decimals, you need to make sure your decimals are lined up and fill in any missing numbers. So here in that last one, 16.2, I need to add in a filler of 0. Bring down your decimal, and you just add like normal. 5 plus 5 plus 0 is 10. Carry my 1. 5 plus 4, because 2 plus 2 is 4. It's 9 plus 1 is 10. So I carry another 1. 9 plus 1 is 10. 10 plus 4 is 14. 14 plus 6 is 20. So I have another 0, carrying a 2 this time. 8 plus 2 is 10. 10 plus 7 is 17. 17 plus 1 is 18. So all together we get 180 degrees. Because this added up perfectly, we would say, yes, this forms a triangle. All right, backside of your practice test, question 9. We need to decide if these triangles are similar. Now, we're proving triangles are similar right now by proving that the angles in the left triangle are the same angles in the right triangle. That means you're comparing the numbers. Well, I can't do that until I know the missing values. So we just find the missing values in each triangle and then compare. Let me start with the left triangle. Remember, this box in the corner means 90. So like we were doing on questions 5 and 6, we're going to add together what we can, subtract from 180. So I have 47 plus 90 plus x equals 180. 47 plus 90 is 137 plus x equals 180. Getting x by itself, I subtract 137. And this tells me my missing x value is 43 degrees. Again, you had to borrow from the 8 to make it a 7, which makes 0 a 10. So right now I know my missing value here is 43 degrees. That's only part of the problem. We need to go to the right triangle, the right hand, like the triangle on the right side of our page, and find this missing value y. Don't trust a picture. Some of you might be like, oh, I'm pretty sure that's 90. That looks like it's a right angle. You don't know unless you prove it. Prove it. Add what you can, subtract from 180, and see, do you actually get 90 degrees or something else? So let's add 47 plus 42 plus y equals 180. Adding what I can is 47 and 42, and that becomes 89 plus y equals 180. Getting y by itself, I'm going to subtract 89. This tells me y equals 91. Because I can't do 0 minus 9, I borrow. 10 minus 9 is 1. But I actually can't do 7 minus 8, so I have to borrow again, make this 17 minus 8, which is 91. So you'd think it looks like it's a 90-degree angle, but it's just a 1 degree more. Now we found all the missing angles, we need to compare. So on the left triangle, I see a 47 degrees. On the right triangle, I see 47 degrees. On the left triangle, I see 43 degrees, but on the right triangle, I don't have 43 degrees. On the left triangle, I see 90 degrees, and on the right triangle, I don't have that. I have a 91. So because all these angles are not the same, we can therefore conclude these triangles are not similar. Why? The angles are not the same. Okay, these next few questions are all related to section 5.5, which is when we are learning all of those names of angles that are cut by, or parallel lines that are cut by a transversal. It forms 8 different angles, and all of these angles have special relationships. Starting with question 10, we have to use the one number we have, which is 84 degrees, and figure out how we can find these missing numbers. Well, angle 6, let me see, what do I know? Here's 84. Angle 6 is on the outside of parallel lines, meaning it's exterior. And what I notice is that it's on opposite sides of my transversal, meaning they're on opposite corners. Well, that's a special relationship. Some two angles that are on the outside of parallel lines are on exterior sides, and on opposite corners are called alternate exterior. Well, what does that mean? Alternate exterior means these two angles are going to be the same degree. So angle 6 would be 84 degrees. My reason is that this is an alternate exterior angle. Well, now let's use angle, one we just found was angle 6. Let's see if we can get to angle 5. Well, I notice that angle 5 and 6 are right next to each other. They're neighbors, and they're on the same straight line. Well, when they're on the same straight line like this, these are called supplementary. What is supplementary? It means they add to 180. So to find the missing value, I just subtract what I know, which is 84 from 180. I can't do 0 minus 4. You borrow. We're going to end up borrowing again. So we end up getting 96. So angle 5 is actually 96 degrees. And our reason is that it was supplementary to angle 6. Now, you can probably find angle 5 in other ways. For example, angle 5 and angle 1 are corresponding, and you might know that angle 1 and 84 are also supplementary. Now, there's many ways you can find it, but the degree, 96 degrees, does not change. Okay, now, this says, question 12, using the figure, name 2 angles that are one of each of these vocabulary words. Now, there are so many different answers. So, you might want to write something different than I do, and that's okay. So, I will list out all potential answers. Alternate exterior. Well, that means I need angles that are outside of parallel lines, but on opposite corners. So, that would be 1 and 8. To save my time, I'm just going to draw my angle symbol once, because all of these examples are angles. So 1 and 8 could be an answer, or another example would be 2 and 7, because these are also outside of parallel lines, exterior, but on alternate sides of the transversal. Part B wants alternate interior. So interior means inside your parallel lines, but on opposite corners. So an example would be 3 and 6, or you may have chosen 4 and 5. Both are options. You only need one pair here. Corresponding. Well, what does corresponding mean? Corresponding means one angle can slide perfectly into another. So, for example, angles 1 and 5 can be slid perfectly into each other. I could have also chosen 3 and 7. Or I could look on the other side, and I could have chosen 2 and 6, and 4 and 8. Any of these are great answers because they can all slide into their respective pairs. Vertical. Now, vertical, it has lots of pairs. Vertical is looking at the corners of where the parallel lines and the transversal intersect, and we're looking at opposite corners of that. So each side makes little bow ties. So let me see here. One option could be 2 and 3. But I could have also chosen the other corner, 1 and 4. These are great examples of vertical angles. Remember, vertical angles are the same. Another set could be 5 and 8. Or 6 and 7, because both of these are located at the intersection and on opposite corners. Oops, I was supposed to say 7. 6 and 7. All of these are going to be the same degree and equal. Now our last set, supplementary. Now this is the lengthy one because you could have listed so many pairs. As long as your two angles were right next to each other on the same straight line, they will be supplementary. Now I'm going to list every single pair. So as long as you have one of these pairs, you are good. We could have said 1 and 2, 3 and 4, 1 and 3, 2 and 4, 5 and 6, 7 and 8, 5 and 7, 6 and 8. And I can actually keep going because what I just listed are some of the more common supplementary pairs. But we also had things that were just called exterior angles and interior angles. So we could have had 3 and 5. I could have had 1 and 7. I could have had 4 and 6, or 2 and 8. Every single one of these pairs are supplementary because in one way they are on the same straight line next to each other, which means they add to 180. So as long as you have one of those pairs, you are good. Okay, our last question on this practice test. It's a long one. Now it has a really big explanation that's truly just explaining this picture. And this picture kind of looks like two triangles being connected at an edge. Well, what I'm going to do is just look at my triangles. What I notice is that there's a top triangle and it's kind of upside down compared to the bottom triangle. So my first step is to rewrite it so that my two triangles face the same way. Because in the end, I'm going to have to figure out this missing side length x. And it's really hard to figure out missing sides if I can't compare it to something facing the same way. So let me rewrite the little triangle right below the big triangle. Let's see, that short side would have been 36. That long side, the bottom, would have been 90 feet. Now we can compare. Well, how do we find a missing side? Using these two triangles. Well, what we do is create what's called a proportion. So we make technically a ratio of sides. Now for us, we're going to make a ratio look like a fraction, where I make one fraction matching up, say, the bottoms of each triangle, and then I make another fraction or ratio that compares the sides of each triangle. So I'm going to go small to big. Does it matter? No. I could go big to small. Doesn't matter. But for me, I'm going to match up my small over big. So the bottom side of my small triangle was 90 over the bottom side of the big triangle was x. And we set this equal to its other ratio or comparison of sides of the small triangle side, which was 36, to the big triangle side, which was 100. Well, these are kind of big numbers. If I can avoid it, I don't really want to have to deal with big numbers because when we solve proportions, what we do is cross multiply. So let me see if I can simplify a fraction, because if I can simplify a fraction, then my math is way easier. I cannot do anything with 90 over x because there's not a denominator yet for me to simplify. But 36 over 100, that looks like a normal fraction. I can definitely simplify it. Now, a lot of you might think, oh, I can divide by 2, and you can because these are both even numbers. But let me tell you, there's actually a bigger number I can divide by, and it's 4. So if I divide top and bottom by 4, this gives me a new problem. 90 over x equals 36 divided by 4 is 9. 100 divided by 4 is 25. Now, what I can do is cross multiply. Cross multiplying allows us to cross out or cancel fractions. So when I do that, the only thing that's left is my equal sign. One loop is 9 times x, which is just 9x. My other loop is 90 times 25. Well, I would do 9 times 25 first, and then you just add your 0. 9 times 25 is 225. Add my 0, which makes this 2,250. Getting x by itself, I divide by 9. Ugh, gross. Look, this is a really big division problem. That's okay. Let's set up our long division. Top number goes in the house, so 2,250 goes inside. 9 goes outside. And we start with 9 into 22. Well, 9 can go into 22 2 times. That's 18. When I subtract, this leaves me with a 4, and I bring down my first remainder, which is 5. 9 can go into 45 perfectly, and it can go in 5 times. Which leaves me 0, but I still have to bring down my extra remainder of 0 because 9 can't go into 0, so it goes in 0 times. So this works out beautiful to be 900. Oops, 9 goes into 2,250, 250 times. So our missing side is 250 feet. Another way I could have looked at this is after I simplified that fraction 36 over 90, I could have seen if there was a relationship between the top numbers. For example, I could multiply 9 by something to get to 90, and that would have been times 10. And if you do something to one fraction on the top, you'd have to do it to the same thing on the bottom. So if I did that, I'd multiply the bottom by 10, and 25 times 10 is 250. Now, this trick doesn't always work out. Cross multiplying always works out. But that is it. So make sure you study your practice test. You gotta know all these vocabulary words because you do not get your practice test on the real test. All right, guys. See ya.